Now, we've seen a lot of stunning images from James Webb Telescope, Hubble Space Telescope about galaxies that are actually distance away, and also some segments of the universe. And there are some interesting properties that are quite hidden that requires a lot of research and a little bit of review. And this is where this article comes into play, where it says that distant galaxies may have some connections that are keeping them together. And one special thing about this particular article is that it's not recent galaxies that we are seeing. We're seeing galaxies that are billions years, like around a billion years after the Big Bang. And these galaxies here, as you see in this particular image, shows that they are circled around how many? Around like 10 galaxies. But take note that we have 8 circles. One of them has 2 galaxies inside it, and there is a common relationship that they all share. And this particular article says that it's some kind of a cosmic web that is created, and this cosmic web is a filament that stays in a less random state and more in an ordered way. And this web has been developing for billions of years thanks to gravity that are keeping all the matter in place together to a more discrete to less of scattered, and so all treacherous according to this article here. And so astronomers, they used the James Webb Telescope's near infrared cameras to be able to identify these 10 galaxies that exist just 830 million years after the Big Bang. And you might be wondering, how long is this filament that is creating this particular system or keeping these galaxies in place? And most likely in more years from now, bringing them closely together to form a cluster. This here is around 3 million light years long structure, which is really massive according to some analysts here. And this 3 million light years across filament or cosmic web is held by a luminous quasar, and this quasar is known to be the brightest and most active part in a galaxy that hosts a supermassive black hole. And this quasar here that is anchoring this particular filament in place here is located at the right side of this image that has the 3 circles right there. And that is really something that is really fascinating to see, how that one quasar is holding that long filament in place that is, some people are calling it, may connect all those galaxies together. Now analysts, they say that the team believes the filaments will eventually evolve into a massive cluster of galaxies that is much similar to the Coma cluster that is produced by Hubble Space Telescope. Now the name of this quasar is JO305/3150. And this interesting result here is coming up alongside a collaboration with the Aspire research group, which Aspire project is known to be called a spectroscopic survey of based halos in the reionization era. Now, you might be wondering that we've talked about reionization before. This here was coming from our previous video that talks about how this here led to the origin of a less visually stunning look of galaxies due to how gases were spread out, to more of a distant look of the universe with distant galaxies, which is due to how gases back then were heated up, and all those incredible transformation that led to the new look that we have today. You can look at my previous video for more details on that explanation. And looking at this particular research here, they're looking at how these events that coincides, of course, with the origins of these galaxies that is around 830 million years after the Big Bang shows this maybe development of these filaments. Now, one thing that comes to my mind is that is it possible to actually visualize this cosmic web that is keeping all this in place? More research will have to be coming into this in terms of hopefully maybe the use of other light in the spectrum, and for example maybe infrared, I don't think so, but something maybe a little bit more powerful like the UV or X-ray vision. So maybe more research will enable us to visualize these filament or cosmic web here that is keeping all 10 in place. Another question is that with all the other galaxies that are around, could there be more galaxies that are actually connected here in a more spread out web system compared to just the 10 circled ones that are shown right here? Now, further investigations are underway in terms of this particular 8 quasars that are aligned in here, and how these here quasars contain massive black holes. And this massive black holes is so massive in terms of the mass is that it is around 600 million to around 2 billion in mass compared to our sun. Now, seeing how massive in growth this actual black hole have is going to be compared of course to how they were during the Enoch re-ionization period. And so this here, coming from a billion years after the Big Bang to what we have right now, shows an incredible growth in the black holes. And what is the cause of this? Now, this article talks about the 2 criteria for creating a black hole. Of course, is that all you need first is a seed, and then that seed has to secondly to grow, and this growth here is due to accumulation of matter or energy from the surroundings. Now, this is really fascinating to see how this is going to show the lifespan of such growth in these particular black holes and how they go into a supermassive black hole. Now, one interesting thing about these black holes is where they are located. They are located at regions where there are young galaxies in there. That means that it's going to be accumulating a lot of millions of matter to itself, and this here can lead to another second point here which comes into play when it is growing so massively to the point where that not only is it accumulating millions of matter, but it's going to be ejecting some other forms of particulates, or some people call it winds, and these strong winds can influence the growth of galaxies that are around it, maybe causing those galaxies to suppress the growth of stars during those regions. And so this is really wonderful to see and understand the process here involved in how we have that much black holes that are aligned in a way and anchored with this massive quasar that is located around the 3 circle area, and how these can sprout incredible results not only in terms of growth of stars but also inhibiting star growth, and most importantly understanding what are the materials that are holding these filaments or this cosmic web together. Many more questions are yet to be answered here, and I hope you join me on future videos about this exploration here, and let us know your thought about this in the comment section down below. By that way, we can talk to you soon. Stay smart as always and believe in yourselves.